Energy is involved in everything that happens. We are aware of energy when it's released or absorbed. Examining the changes of energy in action has led to one of the most important scientific ideas central to all science disciplines. The challenge question for this reading is, what is the guiding principle behind the behavior of energy? Energy in action. Releasing energy and absorbing energy. From our everyday experiences, energy seems to us like it is something that people consume. It often appears that energy is used up, when actually it has not disappeared. Instead, energy is transferred and/or transformed into another energy type. For example, the energy in the food we eat provides thermal energy for our bodies, or the chemical energy in gasoline is released and transformed into the motion of the car. Everyday energy consumptions are really energy transformations in which energy is released. Following energy as it is transferred and transformed shows us a chain of interactions that both release and absorb energy. Take oil, for example. Oil formed in the ground over millions of years from decay of dead plants and animals. The energy in the plants originally came from sunlight, which the plants transformed into chemical energy through the process of photosynthesis. The energy in the animals came from the food they ate. When oil in a furnace burns, the chemical potential energy in the oil is released as thermal energy, which we feel as warmth. The law of conservation of energy. If you compared the amount of chemical potential energy of the oil in the furnace before it was burned to the amount of thermal energy coming out of the furnace, you would find that they were different. There is less energy released from burning oil than there was chemical potential energy stored in it. What happened to the other energy? Not all of the chemical energy in the oil is transformed into thermal energy during the burning. Some was transformed into an energy type that's easy to overlook. In the case of the burner, a small amount of the chemical potential energy in the oil was transformed into light and some into sound, and some remained in the ash and was not released. Sometimes the missing energy from a process is called lost energy. This lost energy has turned into another energy type that is not recognized or used. Sound and light may not be useful energy for heating in this example, but it must be considered part of the total energy released by the burning oil. The total amount of energy in a system is the same before and after a transformation. Energy can be transferred or transformed, but cannot be lost or destroyed. This idea is known as the law of conservation of energy. This means that the total amount of energy before something happens must be equal to the amount afterward, regardless of the process or energy type involved. The law of conservation of energy doesn't say which kind of energy must be present before or after an event, just that the total energy doesn't change. The law of conservation of energy is one of the central principles in science and applies to many disciplines. For example, a biologist can apply this law when examining a food web. Biologists have tracked the amount of chemical energy in a producer, such as grass, through several consumers, such as a cow and a person. It appears that some of the chemical potential energy in all of the grass eaten by the cow is lost before the person drinks milk from the cow. However, a closer look reveals that this chemical energy was transformed into a variety of energy types, including the mechanical energy used by the cow to move around and the energy released by the cow's metabolism. The process of heating. Thermal energy is almost always released during an energy transformation. For example, a light bulb transforms electrical energy into light, but the system loses energy by heating. A hot light bulb is evidence of this. When you drive a nail into a block, the nail becomes warm, indicating that some of the mechanical energy hitting the nail was turned into thermal energy. The process of heating, although useful in many situations and critical to life, is not always desirable. With the light bulb, usually the desirable energy type is light, not thermal energy. Thermal energy that is released during a transformation is not lost or destroyed, but is dissipated or spread out, which makes it hard to harness. Therefore, transforming thermal energy into other energy types of energy is more difficult than many other transformations. Even with the most innovative technology, only about 40% of thermal energy can be converted into useful mechanical energy. Similarly, it is difficult to convert thermal energy into chemical or electrical energy. Although many transformations release thermal energy, it can be a challenge to capture and use it. Energy efficiency. No energy transformations result in 100% useful energy, and people who are concerned with energy evaluate energy transformations by efficiency. Efficiency is the ratio of useful energy that is released to the total energy absorbed by the process. For example, a car's engine transforms the chemical potential energy of gasoline into other types of energy. About 74% of the energy in gasoline is released by heating, but only the remaining 26% is transformed into motion from the engine. Although no energy is created or destroyed, the engine's efficiency is only 26%, or the portion of useful energy that was released. Interestingly enough, since the engine has to overcome air, road, and transmission resistance, it turns out that only about 3% of the original chemical potential energy actually moves the car. Appliances and other devices are rated by the government for their energy efficiency. When a certain model of an appliance is described as energy efficient, it means that it takes less energy than comparable models that produce the same result. For example, a newer refrigerator that has an ENERGY STAR consumes less energy than older models of refrigerators consume to cool the same volume of food at the same temperature. By consuming less energy to do the same work, an ENERGY STAR appliance increases efficiency. An important idea that is related to the efficiency is the term conservation. Energy conservation, not to be confused with the law of conservation of energy, means to reduce or save the total energy transformed in the first place. For example, someone who turns out lights when not using them is conserving energy. Keeping a light bulb off when it's not in use is related to conservation because it will use less energy or conserve energy. Another way to conserve energy is to use an energy-efficient device that uses less energy when it is on. Using energy efficiency saves energy, using energy efficiently saves energy resources, reduces environmental pollutants, and reduces cost. For these reasons, learning how to convert energy more efficiently is a major goal of technology and engineering.